Now there's another situation where you have these points, right? You have these groups, but there's no way that you can just draw a linear line to separate it, right? There's no way you can draw a linear line to actually separate it. Let's see such a situation and then see how we will deal with that one too, right? So let me draw this one here. So let's say we have this. All right, let's say this is what we have. Okay, so let's actually draw, put some points in here. Let's try and then put some points in here. So let's say we have some blue points. So let's say these are some blue points that we have, right? And then let's say we have some points here, something like that. So let's say we have these points over here. Now, if I want to separate these two groups, it's going to actually be difficult for me to just draw a linear line to separate this group, right? So if you take, for instance, if you want to draw a linear line like this, right, to separate this group, it's quite impossible. It's quite impossible. You can see that this one will not work. Maybe what will work is that maybe I can draw this, right? But what a support vector machine will actually do is to try as much as possible to draw a linear line or hyperplane to separate groups, right? To separate the groups, right? But in this case, you cannot draw that hyperplane or a linear line to separate these groups. It's actually quite difficult to actually do that. It's actually quite difficult to actually do that. So let's see how we are going to go about this to solve this problem. All right, let's see how we solve this problem. Now, what we can actually do over here is to try and then find, let's say we want to find the distance from the center of this to each of the points, right? So from the center to each of these red points, right? We can do that. And also we can also find the distance from the center to each of these blue points, right? To each of these blue points. We can also do that. Now, if we try to do that, right, what we are going to realize is that let's say we have 2 points over here, right? So we have x here. So let's name this let's say x1. Normally we use y here, but I'm going to just name it as x2, right? And then let's say we are going to find a distance from the center, right? From the center to each of the points, right? So I'm going to create another variable called s3, right? And s3 is nothing but it's going to be the distance, right? The distance from the center, right? The distance from the center to each of the points, right? To each of the points. Okay, it's going to be the distance from the center to each of the points. Now, if we do that, we're going to realize that the distance from the center to each of the red points is going to be a small distance, isn't it? If you measure from this center, right, from this center to say any of the red points, it's going to be a small distance as compared to the same distance from the center to each of the blue points, right? The blue points are going to actually it's going to actually be a larger distance, right? It's going to be a larger distance as compared to the red points, isn't it? Now we can actually draw another one here. So let me just draw this one over here for you to actually get to understand this better. Now I'm going to transform this. Now, since we are finding the distance, we're creating another variable called s3, and then that's going to be the distance, right? That's going to be that's actually going to be the distance from the center to each of the points, right? So let's say we have this over here. I'm going to do this freehand sketch over here. So let's say we have another one, right? Let me just draw it. So normally this is what initially this is what we're having x1 here, and then we're having x2, right? So now we've created another variable, right? We've created another variable s3, right? So I'm going to name it as S3, right? We've created another variable S3. Now, if we consider the distance, right, as I said, the distance from the center, right, from the center to each of the red points is going to be a small distance as compared to the distance from the center to each of the blue points, right? So what is actually going to happen is that if you want to plot this, then the red points are going to come down, right? Since if this is the center is actually closer to the bottom, right? So we're going to have the red points closer here. So if this is the distance, maybe this is say 5, this is say 10, this is 20, this is say 30, this is 40, right? So the red points are going to be small distance, so maybe 0.5 or maybe 4, right, or something like that. But the blue points are going to have higher distance, right? It's actually the blue points are going to have higher distance. So maybe some of the blue points are going to be something like that, maybe somewhere around 7, 8, something like that, right? Some can even go beyond 10, right? Some blue points can go beyond 10. Okay, some blue points can go as high as that. All right, so that's basically what is going to happen if we want to measure the distance from the center to each of the points, right? The distance from the center to each of the points. So now in this case, if I'm able to do this, then I can be able to draw a line to actually separate this, right? I can now draw a plane or a hyperplane to actually separate these two groups like that. Okay, now I can draw a line to actually separate these two groups. So that is basically what support vector machine would do. And the process of creating another variable, that is the x3, which is nothing but the distance, right, which is nothing but the distance from the center to each of the points, is what we refer to as kernel, right? It's what we refer to as kernel. Okay, so support vector machine is actually going to create several kernels, right? There's just like we test, in this case we test different planes, right? We create different planes over here. So over here too, we're going to create several kernels and then see which one is actually going to help us. Now, if we're able to create a kernel like this, right, or create another variable like this, and then be able to transform from this low space to a higher dimensional space, right? From this space, low space, to a higher dimensional space where we're able to separate this, right? If we're able to do that, then we can actually say that, okay, now the support vector machine work is actually successful, and we're able to transform this from this unseparable situation, low space, to a highly separable space that is in this case a 3-dimensional space. All right, so basically that is it. Now let me actually go to the notebook and then show you this in a more visual and then practical way. All right. All right, so over here you can actually see, so it's the same thing that I'm plotting over here. So I'm just creating, before we worry about the code, I mean, we will actually do a lot of these when we get to the lab session. We're actually going to see how support vector machine works, right? But the intention here is to actually show you how this actually works. So these are just points that I'm plotting over here, right? These are just points that I'm making circles over here. I'm just using this make circle function over here, right, to actually do that. And then I'm plotting, so I'm using scatter plot over here to actually plot that. All right. So this is basically the same thing that we're doing. This is basically the same thing that we're doing over here. So you can actually see over here that it's going to be difficult if I want to, for instance, if I want to separate this, right? It's actually going to be difficult. I cannot actually do that, right? So maybe what I can do over here is to maybe draw this circle around this and say that I've been able to separate it. But that's not the work. That's not actually the work of a support vector machine, right? So what support vector machine want to do is to actually use a hyperplane, right? Use a hyperplane. Or I mean, if there's just a 2-dimensional space, you can call it a line, right? Or you can call it a plane. Okay, what it wants to do is to be able to use a linear separation to separate these groups, right? But in this case, it's going to be difficult for us to actually do that. All right, so we can transform this, right? We can actually transform this from from this space, right, from this two-dimensional space to a high-dimensional space like this, where we can actually draw a plane over here. Now we can draw a plane over here to actually separate this. So we can actually do like that, right? And then we can see that, okay, we have the red points above and then we have the blue points below, right? So we've been able to actually separate this using the hyper plane over here. Okay, so that's basically the job of it. All right, so let me show you one more visual representation of this. Now, if you come here, right, let me get rid of this. Okay, let me get rid. Now, if you go to Total Data Science YouTube channel, you can actually find this over there. Now, watch your screen. What you can see now, you see that we have our yellow points here. Right now, we have our yellow points, and then you can see how the yellow points are being transformed. Right. Now you can see how it's being transformed from the low dimensional space to a high dimensional space. Now we can actually draw a line over here to actually separate this, right? We can separate the blue points. Now you see how the hyperplane is being drawn to cut this, and then we're able to separate the blue lines from the green, the yellow lines from the blue lines. Okay, so let me just repeat this one more time for you to actually get it. So now we have our yellow points, right? We have our yellow points being there, and it's going to be transformed, right? So now you can see that how it is being transformed from the low space to the high space. All right, and then you can see that now it is being separated, right? The yellow points are being separated from the blue points, and we can actually now draw a hyperplane to cut these, right, to separate these blue points from the yellow points. Okay, so that's basically what support vector machine will help us to actually do in this particular case. Okay, now that we have an intuition about what support vector machine is and how we can actually separate it in different forms, right? How we can actually separate this in different forms. Now let's go to the lab session and then see how everything works, right? Let's go and then put this into implementation and then see how everything works. So in the next video, that's what we're going to do. So see you in the next video.